Again, the problem is find this integral. Note 1. If f of x equals e raised to negative x squared, then the diagram of this equation, this function is like this diagram: x, y. The maximum value of f is positive 1, e raised to 0. So we want to show this area, the area's value, and calculate this area. In other hand, this the value of this integral is equal to the area under the diagram of f. Okay. For this, note 2. If f continues on rectangle AB cross CD, when double integral f of x and y dx dy equals to double integral f of x and y dy dx. That is the order of integration over y or x, don't matter, is not matter. So for this, define I equals my negative infinity to positive infinity e raised to negative x squared dx. If f is even, then integral of f of x dx from minus a to positive a is 2 multiplied to 0 to positive a f of x dx. So this is equals to 2 integral of e raised to minus x squared dx from 0 to infinity. So by this, I square is the value of this integral multiplied by itself, 0 to infinity Also, we know that integral of f of x dx equals to f of y dy. So we use y instead of x in the next integral. We have 2 integral of e raised to minus x squared dx from 0 to positive infinity multiply to 0 to infinity e minus y square dy. So you have I square is e minus x square dx multiply to e minus y squared dy. We have 4 double integration e minus x square minus y square dy dx. We can use polar coordinate for calculating this integral, this double integral, but we want to use linear relation between x and y. Okay, define y equals to tx. So we have dy is x dt, because x in this the derivative x is constant. If y equals to 0, exactly t is 0. Is y equals positive infinity, then t also positive infinity. So I square is 4, 0 to infinity, 0 to infinity, e raised to my negative x square, instead of y square, t square x square, x dt dy dx, sorry. For 0 to infinity, 0 to infinity, e minus x square multiplied by 1 plus t square, x dt dx. So we need Fubini's theorem. If f is continuous, this function is continuous on 0 to infinity, or we can say this is positive and finite, equal to continuous, then integral f of x and y dx dy equals to dy dx. So I square equals 0 to infinity, 0 to infinity, x minus x square 1 plus t square dx dt. We want to calculate this integral. Define u equals minus x square multiplied by 1 plus t square. So du is minus 2x multiply 1 plus t square, that is dt, that is x dt, this one, x here, dt here. X dt is du over minus 2 multiplied to 1 plus t square. So when x goes to 0, u also goes to 0, x goes to positive infinity, x square also approach to positive infinity, but we have negative here, but u so to approach to minus infinity. So we have I square equals 4 instead of x dt du over minus 2 multiply to 1, 0 to infinity, e raised to u, that du over minus 2 1 plus t square dt. Sorry, that is dx. This is mistake of writing, sorry. Dx x dx is du over minus 2 1 plus multiply to 1 plus t square. So we have when x equals to 0, u equals to 0, x equals to positive infinity, u goes to negative infinity, 0 to minus infinity. E raised to u minus 2 1 plus t squared dot du dt. Organize this integral by 1 over minus 2. This is can write here because this is constant. Minus 0 to infinity, 0 to negative infinity, e raised to u du. Also we have 1 over 1 plus t squared dt. Integral of e raised to u also is e raised to u, so minus 2 0 to infinity, e raised to u from 0 to minus infinity, 1 over 1 plus t squared dt. So minus 2 integral from 0 to infinity, e raised to minus infinity minus e raised to 0, 1 plus t squared dt. Sorry, we have I square equals minus 2 infinity e minus infinity e 0 1 plus t squared dt. E raised to minus infinity equals e 1 over e raised to infinity, that is 0, that is 1, so minus 1 by minus 2 is 2 integral 0 to infinity 1 over 1 plus t squared dt. This is imaging, and its formula 2 integral of 1 over 1 t squared dt is tangent inverse of t plus c. Okay, that is tangent inverse of t from 0 to infinity. Tangent inverse of infinity minus tangent inverse of 0. This is 0 because tangent of pi over 2 is infinity, so tangent inverse of infinity is pi over 2, so 2 pi over 2, that is pi. This is I square. I square is pi, so I is square root of pi. So we calculate the integral. So integral from minus infinity to positive infinity in e raised to minus x squared dx is square root of pi. Thank you.